Proteins are the building blocks of our cells. Understanding their shape and how they fit together could help us treat pain and even cure diseases. Scientists have been trying to get a good look at some proteins, but for years, the best we could see was a blurry blob. Many proteins are thousands of times smaller than the width of a human hair. Traditionally, scientists use a technique called X-ray crystallography to take pictures of the tiny proteins. For the X-ray imaging to work, it requires proteins are packed together into a stable, organized crystal. X-rays pass through the sample to create an image, but some of the body's most important proteins are too floppy or wiggly to line up into a crystal. Scientists at UCSF have developed a better way to view these elusive proteins.
If you have a floppy molecule at all, they just become more and more challenging to crystallize. Really, the problem was that these are big, complicated systems, and coming up with new ways of studying them required thinking about electron microscopy.
The reason cryo-EM works is that we keep the protein in a very thin layer of liquid, and we freeze them.
This technique is called cryo-electron microscopy. An electron gun shoots electrons at the speed of light passing through the sample. Then a specially designed high-tech camera captures the electrons to form an image.
The camera not only improves the imaging condition, give you a much better sharp image, it can record a movie instead of a steady picture.
If you had a still picture and I was doing this with my hand during the picture, I had a blurry hand picture. But with a movie, you could actually see each of the different steps.
A computer algorithm sorts the images and finds pictures of the protein in the same orientation. Then software builds a composite, an accurate high-resolution, three-dimensional image of the protein.
And we're using the computation method to average many hundreds of thousands of molecules or tens of thousands of them together to generate a three-dimensional structure.
A structure like this one. Yifan calls it the wasabi receptor because it detects the pungent zing in wasabi and onions, and it's part of how the body registers pain. Scientists have known about this protein for years, but now we can finally see its shape in 3D. That means we can begin to build better drugs to block pain.